Whoa, I've never had it say that before. Hello to everyone here, both face-to-face and online, and hello to everyone who's watching in the future. This is a support session for data analytics. It's semester 1, 2021, and I'm just going to talk through working through some regression things. So what I'm going to do is I'm going to share an Excel sheet. And this is a set of pretend data for some pretend people. Actually, I'll just share something else as well. Give me a sec. So here are some pretend people with, they all have names and they have pets, and some of them don't have pets, and some of them have bikes, and some of them are happy and some of them are sad. And they also have 4 different numbers recorded about each person: their age and their height and their average heart rate and their average temperature. I used these cards in a health sciences course recently to do something similar to this, but not in Excel. So I thought it was a handy piece of data that wasn't your assignment, that I would therefore be able to record and put online as a recording to talk through how to make some decisions about doing data analysis. Okay, so these are some people that have all these things recorded about them, and I might be interested in how that stuff is related. So for example, I might be interested in whether people who wear hats are more likely to ride bikes or not. But I can't answer that question using regression, because regression is specifically designed to look at how numbers are related to each other. So since each person, the information about whether they wear a hat isn't a number for each person, it's a yes or no. And the information about whether they have ride a bike is a word. And the information about what kind of pet they have, that's a word as well. And those things aren't going to work for regression, at least maybe next year. If you do econometrics 2, you'll learn about how to deal with those with regression, but you haven't learned that in this course. We can't use regression for the categories. Does your lecturer call that categorical data? Okay, good. Some people call it qualitative data, so I just wanted to check. It'll only work for numerical data, which I'm guessing your lecturer probably calls quantitative data. That's what regression is designed for. So I can only look at the numbers that are involved here and not the categories if I'm going to do regression. I'm just going to check one thing. I just want to see if your lecturer has gotten back to me. Email him some questions about his expectations in the assignment. He hasn't got back, so I can't share that information. Okay. So here is my data. I'm just everybody has all this information, but I'm only able to figure out how the numbers might be related to each other. And that's what regression is designed for. And regression is not just calculations, it's also drawing graphs, and so we're going to do that too. So the first thing I would do if I was going to make a decision of what things might be related to what things is to start drawing scatter plots of the variables that are involved. So I noticed that and I need to think of what things might be related. So I have to have a good idea of what I think ought to be related in order to think of whether they should be in a scatter plot together. So I don't think that these people are all adults. So I don't think that their age should be related to their height, because once you're an adult, the older you are, it doesn't really make that much of a difference to your height until you're like in your 80s and 90s. Maybe you get a little shorter when you're very old, but that's not going to be a problem. So I don't think that I should be looking at that. But just to be sure, I could select those and insert a scatter plot. And I'll just make my window bigger. And that does seem to say that age and height are not related to each other. Because this is the ages along the bottom, it doesn't automatically put an x-axis label And for different ages, the heights are all randomly spread out. There's no particular way of telling what the height is, what the age is given the height, and vice versa. Okay, so that's the first thing, and so I probably wouldn't investigate that one. So maybe I'll investigate height and heart rate. Okay, so that one's a bit more interesting. It seems that maybe if I draw a line along here, there's a very slight downward trend. And so your lecturer would probably say that this was a weak, negative, linear relationship. I think they'd use those words. Yeah, I can't tell yet, but it does seem to be that very slightly, the taller people have a lower heart rate. I made this data up, but I did look up some research that did suggest that. So, yeah. Okay, so that's a relationship that I could investigate. I could run with that one now and decide that that's the one I want to do. Or I could try and make some other relationships if I wanted. So the first thing I would do is try and draw several of the graphs so that you can decide which one. I don't know if your lecturer wants you to describe how you decided which of the relationships you were going to do. Yeah, because in your assignment, you've got 3 numbers that you're trying to decide if they're related, but you only know how to do simple regression with 1 X and 1 Y. So you're going to have to pick which is the X and which is the Y. I would recommend saying something about how you made the decision, but I'm not entirely sure what he wants. So if I was doing this assignment, I would say, I would expect that heart rate might be related to height. And it wouldn't be the heart rate that causes your height to change. So the heart rate would be the dependent variable. And so I would choose my X to be height and my Y to be heart rate. And some sort of, I don't know if you're allowed to use I or whether you have to do it in passive voice or not. It's tradition in science and to do it in passive voice. So maybe it's something like, oh, how would you even do that? It would not be expected. It would be expected that heart rate might be related to height. And heart rate does not cause height to change. Height may cause heart rate to change. And so since heart rate is the response, it was chosen to be the Y variable. Something like that. That's the sort of thing that I would say. Okay, before I move further, does anyone have any questions or thoughts to comment or ask at this point? Yes. Yeah, it's all right to say cause when you're trying to decide what the relationship might be. But yes, it is perfectly reasonable to not say cause ever again after that, because the statistics can never show that things cause things. Is that what you were talking about? Yeah. So if you did say cause, you should always back it up to say the data will only show an association, but won't show causation. But the reason you chose the variables is because you expected there to be causation. I think that's okay. As long as you back it up by afterwards by saying, yes, I am aware that the data won't show it causes. Yeah, but usually your reason to choose which one's the dependent variable is about an idea of causation in your head. And so it is okay to mention that, to say, I expect there to be causation even though the data is not capable of showing that. And so that's why I've chosen this one to be the dependent variable. Something like that. Does that work? Okay, good. It was an excellent thing to bring up. Okay, well, I'm going to run with this one. Okay, so I've got a scatter plot. And this is, if I was writing my assignment, I would literally do that. I would, you know, there'd be a title of some sort, say, you know, their variables, most interesting relationship between height and heart rate, blah, 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 causation, etc. And then I would begin by saying, This is a scatter plot of this relationship. And I would cut and paste from Excel. Probably add labels to your x-axis and your y-axis. So, damn it. Trying to work with two things at once. I should probably share my entire screen so I can just... I can head over here to the heart rate, stick in some axis titles so that I can say that this is height. And then stick in a... It's tradition to put the units in, but with grade, it's okay to not have units because it's just a number, but you could do that as a percentage, I guess. Yeah, and so I could literally copy and paste. And then I would say, damn it, sometimes I despair of a word. There appears to be a weak negative linear relationship between heart rate and height. And she usually mentions three things about the relationship, whether it's linear or not, whether it's there or not, and whether it's strong or weak, and whether it's positive or negative. This is a negative relationship. A positive one would go the other way. It would get higher as it goes towards the left. And you should usually say all three of those things about your relationship, because that proves that you know they're things that you can say, and they're all important things. So it's possible to have a strong linear relationship, a strong positive linear relationship, a strong non-linear relationship, or you could say there appears to be no relationship between these things. That's okay as well. If you really felt like putting in graphs for several of the things, you could do that, but I would only do the actual regression bit for one of them. That would be my advice, because you were specifically asked to only choose one. But I reckon it's okay to draw several of the scatter plots if you want, but I've just picked one. Okay. Okay. So now I'm going to need to try and figure out other things about this relationship. And what I'm going to do is I'm going to go and have a look at this PowerPoint to see what the lecturer said. So I'm going to run through a quick scan through this when I'm looking at there's okay, so there's making predictions. So it looks like we should be finding an equation of a regression line somewhere along the way. I'm going to make a list for myself so I don't lose, so I don't forget anything. And we should be doing a scatter plot. It seems reasonable. Looks like the scatter plot that he's got a straight line on there for the line of best fit. We should add that into ours as well, I reckon. Trend line, linear, awesome, there we go. Pop that in. So you should always tell the person reading it, yep. No, all good. And that goes for anyone. If you have a thing that you want to ask like that, just interrupt me. If you're in the Zoom, you're probably going to have to actually turn your microphone on and yell at me. Okay. So if you've got a line of best fit in your graph, you should tell people that it's there so that they can find it. Yep.
You can also make the equation. So would you like us to make like comparisons between equations on the graph to calculate it?
Not sure yet, but we'll come back to it in a minute. So you can get Excel to put the equation on. Is that what you're saying? Yeah. I'm going to take as a guide what the lecturer has done, and I reckon we're not going to put it in the graph itself. We're going to get Excel's linear regression thing to do the equation, so we can prove that we know where it came from. Yeah. Yeah. Okay. Okay. So, cool. Where have we got? What else can we put in? Okay, so we should get a regression equation. It looks like we need to write the word, write it in words, not with a y and an x. So, okay, we'll get to there, but I just want to know what we're looking for. And we need to probably interpret what the slope parameter means. So this bit just here. Whoa, wow. Did Florian really put a, love it, okay. It's an actual drawing tool thing. It's fabulous. That thing there, I reckon we should include that as well, an interpretation of the slope. Okay. See, this is my way of figuring things out when I do any course, is to say, well, everything the lecturer mentioned, I reckon I should try and mention as well. The size and the direction of the coefficient of slope, size, direction. I'm not sure if it's worth doing a predicted score, but we might want to prove that we want to do that at some point. It seems like a weird thing to do. But just as an example might be useful. So this is how to do it all by hand. This is what I wanted to ask your lecturer, whether he wanted you to show hand calculations. I'm pretty sure he doesn't, or he wouldn't have mentioned Excel in the... Yeah, okay, awesome. So we're going to use Excel and not use these calculations by hand to do it, because that seems like a waste of time if Excel can do it for me.
Express the character.
What was that? Oh, okay. Okay, and then we should include our regression output. And then we should be looking at the diagnostic things. Oh, okay. And we also need to do these 5 requirements on the errors. So we've got a normally distributed. So the mean, normal, constant, standard deviation, independent of x and independent of each other. Okay. So it looks like we're going to have a histogram somewhere in there of the residuals. Standardized residuals. We're going to have a graph like this for homo and or heteroscedasticity. I'm just going to have to stop sharing for a second so I can see the chat. Yes, this is being recorded. Okay. Oh, residuals versus predicted. So I'm just going through the list to find a list of things to do, and we'll actually talk about how to do them when I come to actually do them. Okay, outliers. And then we can do the model diagnostics. We've got the coefficient of determination. We've got that's the R squared. Aha, now a hypothesis test. Okay, I think I'm good. That seems like everything. And then at some point at the end, we should probably, oh, awesome, these are the steps. Really, I should have gone right to the end. Develop a model that has a theoretical basis. Okay, so we have to prove that we have an idea of why things ought to be related. I think that height, heart rate should be related to height because taller people have larger hearts and have more, and therefore their hearts would go slower. If I was health science students, I would have better reasons for that. And if I was looking at the relationship between grades and study time, I might expect the grades to be higher if people spend more time studying. Or maybe I would look at the grades in second year compared to the grades in first year. I'd expect the second year grades to be higher if the first year grades were higher, or whatever. Just talking generally about stuff that might be in an assignment. So there's the data, draw a scatter plot, outliers, residuals, model fit, predict a particular value, estimate its mean. Okay, that's what we have to do. Awesome, I'm so glad he's given me a list, but we've got a few other things that we've looked along the way that we're going to prove that we know how to do as well. Okay, so we have already done the bit where we described why we've done the relationship. We've put a scatter plot in, and we can get negative linear relationship. Since he specifically said that we should say whether a linear relationship is appropriate, we should say, so, how did he say it? A linear model, that's the word he's used. Seems appropriate for this data. Okay, because he specifically asked us to say whether it's appropriate, so we're going to say whether it's appropriate in an actual sentence. Yep. So I was here on the scatter plot, and I went up to add chart element, and it was a trend line, and it was linear. If I do it again, I'll have two of them. Yeah. There's no way of quickly answering that question without just showing you. So it's a very important question to ask because you might have missed it. There are no stupid questions. So well done. No, there are none. Okay, in order to have a question, you have to have been paying attention at some point. So I believe it's not stupid. Okay, so we've done that. And then it said, determine the regression equation. Okay, so at this stage, I think this is where I'm going to start actually doing the regression. Now, my understanding of Excel is it's under data. If you don't have this data analysis bit, you're going to have to turn it on. My understanding of how to turn it on is to go to options here and go to add-ins. Come on, you can do it. Screens for and go to the analysis toolpack and click on it and go, okay, that will turn that on if you don't have it already. I believe that it's in Google Sheets, it's already there. if you're using Google Sheets. And if you're using a university computer somewhere in the university, it should be there already, but that's how to turn it on. Okay. So it was in data analysis. And then there's a big, when my spinning hoop of doom stops, there's a big list of things, all sorts of things that you could learn to do, but one of them is regression. So I have to tell it where the X variable is. I have to tell it where the Y variable is. I have to tell it whether I've got labels for the names. So mine has titles of height and heart rate, so I can tell it that yes, it does have that. I can tell it whether I want a confidence level, and it's 95% is tradition. I can tell it where to put this. I'm going to ask it to put it in a new worksheet. But you can also pick a spot somewhere and put it in that spot instead. I'm going to ask it to calculate the standardized residuals because that's what he said in his notes. And maybe I'll just ask it to do the residual plots and see what happens. All right, it's worth a try. So here it is.
Yeah, I have read that.
Is everything okay? All right. So at this point, I think it would be good if anyone had a question or a comment to add at this point. I want to give people a chance to do that. So when I did the data analysis, there was a button to click that says residual plots. If it isn't in there in yours, I can make one.
I send the questions in the chat.
Oh, yep. People coming in and out constantly. I don't think that's the residual plot that he wants, though. Can I just check in his thing? His residual plot had predicted value and just residuals. Okay, no, it is the one we want. If your computer doesn't automatically create it, then you can make it yourself. Because we asked it when we did the regression. So when we did the regression, we asked it to produce the standardized residuals. They should have appeared, sorry, in the data here. And we have the predicted height and the standardized residuals. We should be able to select those two. I'm holding down Control or Command if it's an Apple, and draw a scatter plot. Like that. And that's a graph of the height and the standardized residuals. Is that similar to the graph we had here? Yes. Okay. I'm just going to look at his list again, because this is what was automatically produced by the computer, all this stuff. And I'm going to need to find everything that I've been looking for in here. So his list said, determine the regression equation. So I've got this output. What I'm going to do is over in my Word document and say a.
So based on the first question, I think I will make a judgment on my ability. Of course,
Yep, keep
I
going.
think before that, if I do not know what the type of the family business is, or I don't know how to measure it, I think I can not be some important role in the firm, and the other stuff will not be will not trust me. Think that.
I'm really struggling to understand what's going on there. This is a workshop for data analytics run by the Maths Learning Centre. Is that what you were talking about? All right. And I'm also having trouble hearing you as well. So if you want to say that thing, feel free to pop it in the chat instead. Brandon, yes, it will be uploaded. It won't be, it'll be in my media, sorry, what's it called? Echo 360, but it'll be a direct link to that because I don't have access to your course. So it will be there. Okay, so I'm going to keep moving. So I would literally cut and paste this output so that they know what it looks like.
I think when the business is profitable, or
okay, just a second. Can you stop? You're saying a business is
sometimes companies need to set the how to say succession plan as early as possible, I think.
Are you talking about data analytics? Because I'm having trouble, I don't know who was talking. What I'm going to keep doing is keep talking about data analytics because I don't understand how that relates. I'm very sorry. Okay, right. Okay, so I've cut and pasted the results from the Excel in here, and this is where it is, just so that the person reading it knows that I've done it in Excel and that where I'm getting all of my results from when I do this, when I write the next thing. And so now I can say after this, well, now what did he call it? The regression equation. So the regression equation is somewhere here. These are the coefficients. That's the intercept. That's the coefficient of heart rate. And sorry, that's the coefficient of, oh, just a second. I feel like I might have done something wrong. Oh, I think I've done this. Just a second. Let me go back to my Excel. Let me just go back to here. Data. Regression. So the X is in C, so that is height. Okay, cool. And the, no, I've done it backwards. This says input Y range, and I've put what I thought was X in that spot. So I'm gonna have to do it again. So this should be the heart rate. And this should be the height. So it asks for the Y first. Okay. Sorry about that. Okay, what clued me in was that in this position here, it's supposed to be the name of the X variable in that spot. And when I put it over into here, the name of the X variable, it said heart rate, and I'm going, just a second, it's using heart rate as the X variable. That's not what I want. So I'm going to delete that table and try again. All right, so the regression equation is heart rate equals 246 times 329 minus 1.00157 times height, like that. So he wants you to have a big hat on the top of the heart rate. I have a plan. And put in an equation. Is there one with a hat? Yes, there it is. Come on. Like that. And then I've got a nice little hat over the top of the heart rate. Awesome. Hello. Okay. That's the regression equation. And then what else did he tell us to do? In the notes, he said to try it for a couple of values. And so I would say, I'm going to do that even though he didn't ask me to. I'm going to say for example, we should interpret it too, shouldn't we? So I've said that we should interpret the slope. So the slope is minus 1.00157. So for each centimetre in height, the average heart rate decreases by 1.00157 beats per minute. So you should include the units. So if you're going to say like an hour extra study increases the result by 5 percentage points or whatever. So that's, we've interpreted it. And then we should probably also say I feel like I should do this first. For example, for a person with height, I should pick a height that's reasonable based on the people we have. Let's go 160. And then I reckon I would put the conclusion like 246.329 minus 1.00157 times 160, which comes out to whatever it is, and I need a calculator for that. I could do it with Excel, I'm sure. $86.08. Ah, damn it, not doing well. And then maybe do another one as well. But I can't be bothered actually doing it. But I'd pick another number at the other end. You've got a sort of a shorter person and a taller person. Yeah. So these are just ways of interpreting this equation, and I think it'll be really useful to put them in so that we can prove that we know how the equation works. Any questions at this point about what I'm doing here? Okay. So we've done the regression equation and we've interpreted how the regression equation works by showing that we know how to calculate with it and by showing that we know how to interpret the slope. And then what else did he say? Calculate the residuals and check all the required conditions. Okay. Maybe this needs a heading or something. I don't know. You can decide on the grammar. I don't really know what he's wanting. And since he has given you no instructions, it just has to sound okay. All right. So he says that the mean has to be 0. So we should figure out the mean of the residuals, I guess. So where did my residuals end up? This one's the old ones that's wrong, isn't it? Okay. So these are the residuals here. It's not called mean in Excel, it's called average. So what I typed is the average of that column where the residuals were, and it's telling me a minus 8.8 E minus 16. That E is telling me times 10 to the power of negative 16, which means there's 16, it's 0 point and then 16 zeros, and then the 8 starts. And so that's approximately 0. So I could say, okay, that was the first condition. I reckon we should do 1. And then what was the 2 thing? They have to be means, so the distribution of the residuals has to be normal. So we should be selecting the residuals and drawing a histogram. Insert histogram. Oh, that's not nice. Format. Series options. No. I always forget how to do this. Here we go. So I have to format the axis. So I need to click on the x-axis, format that x-axis, and change the number of bins to something more reasonable like 7 or even 10. Doesn't look normal, does it? That's not very nice. It's supposed to be normal. So you're supposed to see a neat little normal histogram. That's not very nice. I'll try again. Yeah, it looks skewed, doesn't it? So I'm just going to copy that in. This is a histogram of the residuals. The distribution is not particularly normal. It's supposed to be normal, that's the requirement. Does your lecturer use right skewed or does he use positively skewed? What sort of? Okay. So unfortunately, I'm probably not supposed to do regression since the residuals aren't normal. But I'm just going to say I'm still going to do regression anyway. So I'll make a comment somewhere because he did say if you can't continue because there's problems, just continue anyway. And so that's what I'll do. Probably what I'd say is that the normal distribution assumption is okay for when there's a lot, even if is okay to not be satisfied if there's a large amount of data because of the central limit theorem. Can I just check, is central limit theorem a phrase in this course? Okay. Oh, this requirement, isn't it? That's what he called it, isn't it? Okay, I can say that. Good, beautiful. Hopefully in your assignment, it will come out looking nice and normal and you can say, well, it's normal, and then for the requirement is satisfied. Okay, what's the next thing? So the next thing on my list for the requirements is that it has to have constant standard deviation for various values of the predicted variable. And your lecturer did that with that scatter plot. Yep, there it is. This is the scatter plot of residuals versus predicted. So we should do that too. That was this scatter plot here. It's off the back of the page. Come on, people. Okay. So what we're looking for is that the amount of spread is the same all the way along the line. So you won't draw these pictures in the oh, that's bad. You won't draw these lines in your assignment, but the point is that if you have if you divide it into like quarters, whoops, sorry. I should make them thinner, shouldn't I? If you divide it into quarters, it should be possible to go, oh, well, it's roughly evenly spread in each quarter. Oh, damn it. So in each quarter, this middle one is probably a little wider spread than this one, but it's not too bad. What you want is it not to be, at no place do you want it to be twice as spread out as anywhere else. That's pretty much it. And so I would say in this plot, the points are roughly evenly spread at every horizontal position. Evenly spread vertically. They're evenly spread vertically at every horizontal position. So as you move horizontally, the amount of vertical spread is roughly the same. Actually, that would be easier to say. So in this plot, as the viewer moves horizontally, the amount of vertical spread is roughly the same. That's another way of saying it. And if you really want to sound fancy, you can say, so the data homoscedastic. That's the terminology, homoscedastic. Some people spell it with a K, some people spell it with a C. I reckon we should check what the lecturer calls it. With a C. Okay. All right, I'm going to remove these things because they're not necessary. They're just for us. You would only say it was heteroscedastic if it was really obvious that it was much wider at the one end than it was at the other. It doesn't really matter as much if it's much wider in the middle, if it's a little bit wider in the middle than it is at the edge, because that might just be because there's more data in the middle. So if you really wanted to talk about it, you could say it may appear that the data is more spread in the center, but that is probably just because there's more data in the center, if you really want to. But I don't know if he really wants to see that. If you're getting close to 1,000 words, then cut it out. Okay, so cool. That's the what's the fourth one? So I'm just going to say, how are people feeling at the moment about what we're doing here? Feeling like you've got a good plan? Awesome. I'm excited. Okay, what's the fourth one? Okay, the next one says that the residuals should be independent of X, meaning there should be no particular pattern to this shape here. What you don't want is that for lower heights, for there to be bigger residuals, or for the residuals to all be positive when you're lower heights and all be negative when they're lower heights, or there to be like a curve. And so I would say in I'm going to read it out in a second. In the residual plot, there is no apparent pattern to the residuals, so the requirement that the residuals are independent of X is met. Something like that. You can say it in lots of other ways than the way I've said it, as long as all the ideas are there and it's grammatically correct, it should be okay. And in general, I would recommend that you don't exactly copy what I've said, but he's going to read so many of these that I don't think it matters that much. But it's good to, if you've got friends that you're working with, try and make them all sound a little different. Sometimes there's only one way of saying it that is mathematically correct. So here, for example, when I interpreted the slope coefficient, this is pretty much the only way to say it that is mathematically correct. And so it's okay for everybody's to be the same for that one. Yeah. But this one, it's a bit more fluffy. You know, I could have said, there's no pattern that is visible in the residuals instead of no apparent pattern, you know, something like that. Okay, and what's the last one? They're independent of each other. So the residuals being independent of each other cannot be assessed using a graph. It could only be assessed using a graph if you had extra information. So if you had extra information such as what location each of the individuals was in, or what order the data was collected in, then you could draw a graph of residuals versus time. And it may be that the residuals gets bigger as time goes on. And then you would say, well, actually the residuals is related to the time it was collected, so they're not independent. But without any of that extra information, we have no idea. And so all we can say is, there was no way of knowing if the individuals in the data are independent of each other. Is not met. But if you'd been told it was a random sample, then you'd know they're independent. I'm going to say, however, the analysis will be done assuming this requirement is met. Run with it. But you have to mention it because it's in the course. And it's not just because it's in the course, but because it's important to mention it. But it can't be done with a graph. It can only be done from the story. Okay. So we've done the requirements. What else was on his list? Assess the model's fit and significance of the coefficients. Okay, we're doing well. Okay, so the model's fit was done with the coefficient of determination. I'm going to put an equation in because R squared is there it is, 0.30702. Close enough. I reckon we should probably interpret this. The R-squared coefficient is the percentage of the variation in the outcome that is explained by the variation in the independent variable. So we would say approximately 31% of the variation in heart rate is explained by the relationship with height. And that's another one of those, there's not really many ways of doing it so that's mathematically correct, so it's okay to just copy that phrasing. And thanks for coming.
Thank you.
The rest will be recorded. No, it's all good. I really thought this would take shorter than this, but I'm glad to just do it comprehensively. So that's the sort of thing that you need to say to interpret what that means. I would say that's a weak relationship. So a strong relationship would be like 80% or 70 to 100%. This is probably a moderate relationship. I don't know if your lecturer's given you a list of what percentages go with what. In psychology, they give you a list, but because everyone does statistics, but not. I don't know if your lecturer's given you one. Has he? Okay. All right. I'm going to say it's a moderate to weak relationship. Good-o. Okay, which we knew. That confirms what we said in the scatter plot right at the beginning. So that's fine. You can even say that. Beautiful. Yes. You'll find that it's really hard to get anything above like 80%. Yeah. And it's not that unexpected. I mean, there would be a lot more things than height that would explain your heart rate. There'd be your fitness level, and there'd be family history and all sorts of things that would explain heart rate. So you wouldn't expect it to be too high. All right, anyone got any questions about that? Sweet. And so the rest of it would be the significance of the coefficients. As far as I'm aware, it's not worth doing the significance of this one, the intercept, because that's not really very important. But you do want the significance of the coefficient that goes to the slope coefficient. So this is called, I'm just going to see what your lecturer talked about it, testing the slope, T statistic. So to assess the significance of the relationship, the t-test for the slope was conducted, I feel like I want to just copy what he said about the hypothesis that goes with this. The hypothesis is that the slope is 0. I might have to do that in the H naught beta equals, oh, he calls it beta 1, doesn't he? And what does he call this? HA. I personally wouldn't do this if I was just doing this myself as a statistician, but we want to prove that we've read the notes. You can select those things from a menu when you're doing the equations if you want. There's a menu of different things. There's a not equal sign. I just happen to know that if you type \NEQ and not equal, it'll produce it. And if you type \beta, it will write a beta, which is just something nice. I'm just familiar with how this works. Was t equals, now where was it in the data? T equals minus 3.64578. Whoa, wrong one. From a t distribution with, we have to say how many degrees of freedom it has. There should be the amount of data minus 2. But it will tell me the degrees of freedom somewhere. No, it won't. Ah, cool. So my data says there's 32 observations. So the degrees of freedom is that minus 2. Let me just check. Yep. So this is the same sort of thing that he's done. in his thing. He said it has a t-distribution with 98 degrees of freedom. He had 100 amounts of data and he took off 2. You have to take off 2 because you're doing regression. It's a 2-dimensional thing. When you're doing an ordinary t-test, it's only n-1. If you're doing a t-test in regression, it's n-2. And later on, if you did a multiple regression with more than 2 variables involved, it would be n minus how many variables there are involved. If you ever do that in the future. I believe Econometrics 2 is pretty much all regression, that course. So if you ever do that course in the future. Okay. My p-value was 0.001. And since my p-value is less than 0.001, the relationship is significant. I think that's sort of what he wants to talk about. At the 5% level. Yeah. It's also significant at the 1% level, so I could do that too. But it's traditional to use 5. Feel free to leave at any time if you need to. So we should probably say, so the null hypothesis. So rejected at the, I'm just trying to copy his wording. You reject H0, yeah. Conclusion of the relationship between is significant. I'm just going to leave it as significant. Something like that. What else has he said? Oh, we did the predictive. We did the predicted values back at the beginning, so that's okay. So I reckon at the very end we should have a bit of a summary. Well, before I move on, anyone want to ask about that t-test stuff? You might not want to today, but feel free if you want to come to the Maths Learning Centre to chat about it later before your exam, then feel free to come and chat about it then. Okay.
Right, just quickly.
Yeah.
Which value of the t-statistic did we use? Was it the
Yeah.
one where it was the x value, the height one?
So you've got to use the one that goes with the name of the variable, which is this one. Perfect, thank you. That was an extremely important question. Good noticing. I'm just going to reiterate that one more time. To assess the relationship, you need to look at where the slope came from, which is the row that has the name of the variable that you've got. And I went along there, and this is the t-statistic, and this is the p-value that went with it.
So we won't be looking at the intercepts row?
No. We did use it to get the intercept in the equation itself, but that's pretty much it. It's not really important to know whether the intercept is significant because that p-value there goes with the asking the question, is the intercept 0? And it's like, well, of course it isn't, because when people have height 0, the heart rate isn't 0 because that doesn't make any sense. So yeah, we don't care. It's very rare to need to look at the intercept at all. Also, I'm loving the questions. They're good questions. So if I was at the end, I would make a nice little conclusion right at the end. because otherwise it would feel like the assignment wasn't finished. There was a significant negative linear relationship between height and heart rate, however, was weak. That taller people have lower heart rates. Maybe I put the regression equation in at this point. However, the relationship was weak. Something like that. And so you might end up with, there was this significant linear relationship between amount of study and grades, so that people with more study have higher grades on average. And also this relationship was strong or whatever. I don't know what's going to happen when you do it. Could be anything. I'm presuming that your lecturer has carefully set up the data so that something is going to be there. But it was also perfectly appropriate to go through all of this and say, there's no relationship. And say, there was no relationship between this one and this one. And, you know, there was no relationship between height and age. And so given a person's age, it was not possible to predict the height from that information. And that's a perfectly good conclusion. Unfortunately, what it doesn't do is show that you know stuff about how this works. And so I would recommend picking one that did have a relationship just for the purposes of the assignment. But if you're doing real, you know, science, then it's totally okay to have one with no relationship. Yeah, just wanted to point it out. It's important to know. Yeah. Any other thoughts or questions about this topic of regression that anyone wants to ask? You know, I've gotten to the end of what I think my assignment would be. I mean, at this point, I'd probably go back and check that my wording made sense, and I'd show it to someone to see if I'd picked up any spelling or grammar mistakes and that sort of thing. Like, sort of obvious, but you don't want to. Yeah, and I'd show it to one of my friends and say, does this say what I think it says? Yeah, so cool. But anything else that anyone want to ask about regression or at the time?
Yeah.
Yep.
Sorry, just a quick question. You know how you drew the residual plot for the standard residuals and the predicted residuals? Did you end up putting that one in, or did you just use the one that was generated?
I was a bit confused because in the lecturer's notes, his graph
I got confused as well.
His graph had ordinary residuals and predicted value. And so I feel like that's what we should do too. So you're right, maybe I should just cut this one out and go back to here and do the one that actually had the predicted values and the standardized residuals, hey? Do you reckon? Because he did say to use...
I'm not too sure. Can we put both in, or?
I reckon you should only put one. He's not been clear about exactly which one you're supposed to do, but he did say in his notes that you should calculate the standardized residuals. But then his graphs don't match that, so I'm a bit confused, but he did explicitly say in his words to use the standardized ones, so I reckon we'll do the same. Because that's what the words said. And this one turned out really weird. I would change the minimum to be something a bit more reasonable. There we go. And I'd stick in an x-axis label. And put in like predicted value. All right. I mean, honestly, in the end, if I'm honest, he's probably not going to read it. He's just going to look at the picture. And so it probably doesn't matter. So decide based on how much time you've got left, is what I'd say. But he did say to use standardized residuals. Oh crap, I should have put a y-axis label in. Anyway, it'll be roughly the same graph. Yeah. The only other thing I'd mention is that if you see at any point a big outlier that's a long way from anything else, you should mention it, but I don't know if you have to do anything. So I think sometimes you get one where it says 0 for one of the values. I'd probably cut that person out because they were lying. They're really lying that they didn't do any study at all. Maybe not, but anyway, that doesn't sound right. You'd have to at least read the assignment instructions, and I count that as study. Yeah. So I haven't got any outliers in mine, I'm sorry. Yeah.
Just another question.
Yeah. Go for it.
With the hypothesis, right? So
Yeah.
for your values you've generated standard error and you've got upper 95 and lower 95 in the Excel.
This thing here?
Yep. So can we use the t-stat to determine whether our hypothesis is correct or not?
You can, but you'd have to go and look up the critical t value for the correct t distribution.
Right, and would that be using the t-table?
Yeah. So you could do that. You could go and look up the critical t. For us was 30 degrees of freedom, and so it'd be about minus 2.1 or something. And then you'd say my t statistic is larger than the critical value, like larger in size than the critical value, and therefore we reject H0. Is that the sort of thing you were thinking of? Yeah.
Yeah, that's exactly it.
But since the machine has given you a p-value, it's totally okay to use that instead.
Yep, no worries.
But yeah, that's how you do it. So this upper and lower 95%, that's actually a confidence interval for the, that's a confidence interval for the slope. So if you really want to mention that, the slope coefficient is this, you could say a 95% confidence interval . Does your lecturer do like number?
He does number, comma, yep.
Yeah, okay, cool. -1.
Yeah, because this is what I've done.
Yeah. I don't know how many decimal places he wants. 5 seems a bit excessive. And so that would be that. So one. So I've got, so for 170 increase in height, the average heart rate could be expected to decrease by between this number and this number. That's how I interpret a confidence interval for a slope. It's the same as the confidence interval, the interpretation for the slope, but it's between here and here.
Yep, I got that. All right, thank you for that.
Yeah, I don't know if he wants it, but you know, it's another piece of stuff that you could prove that you knew, I guess. So chuck it in. Yeah.
I've also got a question.
Yep.
So before, when you were explained how to get the graph that you did,
This one
my
here?
laptop. No, the first one. So the very first one. But my laptop shut down, so I missed how you got the statistics.
Oh, the very original,
right
this
now
one
in
here.
Excel. Yeah, I just missed how you got the statistics on the table on the other Excel document.
Oh, so you mean, how did I get all of this stuff?
Yeah, was that just by the Excel calculations, or?
Yes, that was from the Excel calculations. So what I did is I went to data. I went to data analysis, and there's a spot for regression on this list.
Yes.
And then I selected where the data was. So just I had to be very careful because it says y first. So you have to do the y variable
Yes.
first, which was heart rate. And I selected that. And then I selected
Yep.
the x variable.
Yep.
And then I told it that I had labels because it had titles at the top there.
Yes.
I told it what confidence interval to use. I told it to put in the new worksheet. I asked it to do the standardized residuals and the residual plot. And then when I clicked OK, it made a new sheet with all of this stuff.
Okay, so it's in the data part and then
Yeah. So if it's the data ribbon here, the data
Yes.
tab, and there's a data analysis here. If you can't see this data analysis section,
yeah, mine doesn't have that.
then you have to go to options and add-ins and turn it on.
So options.
Mhm. So when I'm in options here, there's an add-ins section.
Sorry, how did you get into options?
I went back to file,
Yeah.
and then right down the bottom, it said options. I don't know if yours has.
Okay. Yeah, I think I might need to update mine. Mine's just different. That's all right. I'll
Yeah.
update mine and then try and do that.
If yours is in a Mac, it might be look like it's in a different spot. Different versions of it is in different places. Yeah. So it would be worth Googling, how do I turn on the data analysis package for your particular version? Yeah. Cool. I'm pretty sure that in Google Sheets, if
It's
you
a
have
data-
access.
Just
Yeah. What's that? Could you say that again?
Oh,
Pretty sure it exists in Google Sheets. I'm not 100% sure. Regression is not something that it does all by itself, unfortunately. You have to turn on this analysis package. But this is what was in his notes, this stuff, in his PowerPoint slides. And that's how I got it to do that.
okay. Yeah, thank you.
All right. I'm going to stop there. I've been talking for an hour and a half, and it's time to stop. I'm hoping that was really helpful. The video will appear somewhere at some point. And if you have any other questions about this course, feel free to pop into the Maths Learning Centre. We're open all the way to the end of the exam period. Really good idea to bring things like the lecture slides, because every discipline does statistics a little bit differently. And every new lecturer, every new year for the same course, you get a new lecturer, they do it a bit differently. So it's really important to bring the resources you've got so that we can look it up and make sure it matches with what he said. I'm the one who's got the most experience with statistics. The other staff will be able to muddle through, but I'll probably be a bit quicker. But I'm also the coordinator, which means I'm the one who has to go to meetings, so I'm not always there, and I can't tell you when I'm going to be there. But I'll try my best to be around as much as possible so I can help you out. Thanks so much for coming. I wish you very much the best with this assignment and with your future studies and all the rest of your courses as well. And if I don't see you, then I will assume that you're okay and well done. And if I do see you, then I'll assume that you've been proactive and sought help and well done too. So good luck.